Moving on today, we got a lot to cover. We're going to go a little more in depth than you've probably done before in this stuff. However, before we get to this, I do want to talk about a concept that's going to pop up a lot for us, and that is the idea of dogs versus golden retrievers. And it popped up a little bit when Lexi was explaining her problem, and that doesn't make any sense to you right now, but you'll understand in a second. So I always refer to this dogs versus golden retrievers example when we're talking about how things relate to other things. For instance, I think you all understand that every golden retriever is a dog. Yes? Okay. However, not every dog is a golden retriever. For those of you that have a math mind, you could represent this, golden retrievers and dogs, using a diagram like this. Every golden retriever is also a dog. But not every dog is a golden retriever. You might have a schnauzer, pit bull, etc., etc. Anybody happen to know what kind of diagram that's called, by the way? No? Maybe you've seen it this way?
Yeah. Oh, Venn diagram?
Venn diagrams, very good. Okay. So, if you'll recall, when Lexi was describing how she solved the problem, she put the point that was between the other 2 points in the center of the segment. And I asked her, did she need to do that? She fully admitted, no, she didn't need to. She just wanted it there. That's going to become relevant to what we're going to do today when we talk about midpoints. Okay. And the idea is going to be that all midpoints are between, but not all points that are between are midpoints. Okay? So, what is a midpoint? You're writing a definition. Go ahead. While you're writing that definition, you want to ask yourself, what makes the midpoint special from all those other points on the segment? Colin, what do you got for me, buddy? What's a midpoint?
I said a midpoint is a point in the exact middle.
Whoops, hold on a second. What am I doing? Let's try that again. A point in the exact middle. All right. Middle of what?
A line.
Okay. Middle of a line. I would say almost perfect except for one small thing. Anybody have a problem with his definition or realize what the small thing is?
Line segment.
Yeah, there you go. You understand why that's relevant, Colin? Lines go on forever, therefore you can't find the exact middle, but all of a sudden when you turn it into a line segment, it works perfectly. Since this is the definition we're going to use the rest of the year, does anybody have any problems with it? Do we need to add anything or eliminate anything from this definition? Or are we going to give Colin full authorship? Okay. There's a line, segment, PQ, with the midpoint M, and you'll notice the tick marks there show you that it is smack dab in the middle. Now, before I show you that paragraph, when you learned about midpoints in the past, probably last year in algebra, you had a formula to memorize. And some of you have excelled in mathematics because you're good at memorizing. And so some of you are just going to ignore this top paragraph and you're just going to memorize that formula at the bottom. The problem is if you just memorize that formula at the bottom, you don't understand what you're doing. When other formulas appear that are similar to that, it's going to cause some problems. Okay. The top paragraph explains how to find the midpoint. It is the average of the x coordinates and the average of the y coordinates. Well, notice, x1 plus x2 divided by 2 would in fact be an average. The other mistake that happens a lot when dealing with midpoints is that people get a number for a midpoint. And remember, it's got to have a location. So it's got to have an x value and it's got to have a y value. Okay? Questions on that? And I know you've seen that before, but again, I have a feeling that many of you just memorized it and puked it up. Okay, so let's put it in motion. Find the midpoint of the segment ST.
Can you go back for a second?
Sure. Via, was that you talking?
Yeah.
Okay, so I want to make a point that all you have to do is exactly what she just did. Ask me to go back, or if you don't want to do that, as I mentioned earlier, I'm recording this lesson and the slideshows will be available later. So if you want to copy down this entire slide, if you don't have enough time to do it now, you can always get it later if you just leave some space in your notes. Okay? Everybody good? All right, so find the midpoint of ST. Natalia, what do you got?
I'm not done with it yet.
Okay. Let me know when you are. Okay, you're up. What do you got?
I got negative 5.5 and negative 2.9.
Okay, so I'm going to do this as negative 11 halves if you don't mind.
Okay.
Because I want to keep it in fraction form. And then what'd you get for the other one?
Negative 2.9.
2.9? How'd you get that?
Yeah. Oh, I mean 5.
Oh, there you go. Okay. In other words, negative 5 halves. Okay. And again, we want to leave it in fraction form because it's more accurate. Now, what she said is perfectly correct. These are equivalent expressions. So why am I making you leave it in fraction form? Because we're going to get to some things like this, and that is not equal to that. So as long as we stay in fraction form, we're guaranteed to always have the correct answer. Okay, well done. And I'm assuming you all know how she got that answer. 3 plus negative 14 divided by 2 for x, and 2 plus negative 9 divided by 2 for y. Great. All right, now let's make it a little bit more interesting. Before you just start diving in to calculate a midpoint, make sure you read the problem. And you might also want to draw a picture to go along with that problem to solve it. Go. How many classes do you guys have today?
3,
3?
4, but I don't have gym.
Oh yeah, that's same as
How are they handling gym when you're in school?
We have to sit in the
Still fine. Okay, so it becomes like a study hall on those uncomfortable bleachers, or do they have chairs for you?
Chairs.
My last period's gym, so I get to go home early.
That's not
Yeah.
acceptable.
I get to do that on 8 days.
What period is your gym class?
Uh,
1, 7, or 8? Or 5, 1, 7, or 8?
after this.
Okay, so after lunch, so 7.
Yeah.
Okay, well, that sucks. Yes, they're up for 70 minutes for 8th period. That's horrible. Answer, anybody? You guys get it? No? Answers, anybody? Let's see. Take this, and we have K here, we have L here, and we have M there. That's equal to that. I know that M is at 5, negative 6. I know that K is at 1, 2. I'm looking for L, so I'll call that X, Y. All right, I'm going to show you two different methods to solve this. Doesn't sound like anybody got it, but there's an easy way and a hard way. The hard way is more mathematically straightforward, not straightforward, it's more mathematically sound. The other one is an easier method to solve it. So, since I don't know what L is, I called the coordinates X and Y. And if I knew L and didn't know M, I would solve it just like, I think it was Natalia, you did number 1, right?
Yeah.
Okay, beautiful. I would take the X coordinates, add them up, divide by 2, and I would get the X coordinate of the midpoint. Okay. X coordinate of the endpoints added up divided by 2 gives me the X coordinate of the midpoint. Solve that equation. Multiply both sides by 2, and X would be equal to 9. Repeat the same thing with the Y coordinates. Add up the 2 Y coordinates, divide by 2, and that has to equal the Y coordinate of the midpoint. So that would give me Y equals negative 14. Okay. That's the more mathematically sound way to do it. However, there's a more practical method, and that is, let me get this out of the way. I'm going to ask myself a real simple question. What did I do to go from 1 to 5? Whoops. Let's try that again. What did I do to go from 1 to 5? I added 4. Therefore, to go from 5 to X, I add 4, 9. What did I do to go from 2 to negative 6? I subtracted 8. Therefore, I subtract 8 again. Negative 6 minus 8, negative 14. 9 comma negative 14. We're talking about points, so it should be in parentheses. I don't care what method you want to use. However, if you use the method that I just used, the second one, you need to show work. Well, how do you show work? That picture will constitute work. Questions? Beautiful. You guys good? All right. Solve it. And again, I would draw a picture first. Any ideas? Did you have a picture? Okay, good. You don't like the crayon?
I don't. It's dead.
Oh.
It died so quickly. And then,
It shouldn't. How quickly did it?
well, it was like right when I got it. So then I just like haven't charged it since.
Okay. So it's all on you.
Yeah.
Okay, just check it.
Yeah.
Marcus, what do you have for an answer?
I'm not sure.
Okay. Rachel, how about you?
I got 11x minus 4.
Oh. All right, let me write that down. How'd you... Oh, I see what you did. I'm assuming that you got that by taking 14x plus 2 and subtracting in parentheses 6 minus 3x.
Yes.
Okay. But you did your math wrong. Because notice I'd have to distribute the minus sign, so it would become 17x minus 4. Okay, but I'm still with you. I got the idea. However, I want a numerical answer. So is there a way that I could take this, or take the work that you did, and find out what x is and get a numerical value?
Yes, but I'm not sure how.
Okay, let me ask you another question. How long is PO other than 17 minus 4?
It's half of PR.
Perfect. So I could say it's 7x plus 1. Right?
Mm-hmm.
Awesome. So you've just created a monster that I love. This is a different way to solve the problem, which I didn't consider. So let's back up for everybody if you're not following what's happening. I asked her how long PO was, and she said, well, it's half of this, which is perfect because it's a midpoint. So half of 14x plus 2 is 7x plus 1. Okay, Rachel, what do you know about PO and OR?
It's half of PR.
Yes, and how do PO and OR relate to each other?
Yeah, wait. I'm sorry, what was the question again?
How do PO and OR relate to each other?
Oh, they both equal PR.
Added together.
Mm-hmm.
Right? Okay, so we could say 7x plus 1 plus 6 minus 3x is equal to 14x plus 2. Okay, so that's 4x plus 7 is equal to 14x plus 2, which means that 10x is equal to 5, so x is equal to 1/2. Perfect. That's method number 1. Method number 2. I know, because of these tick marks, that these two puppies have to be equal to each other. 7x plus 1 is equal to 6 minus 3x, so 10x is equal to 5, x is equal to 1/2. Second method. Okay. Third method. I know that this is half of this, or this times 2 equals that. So I could, let me get this out of the way. I could set up the following equation. 6 minus 3x times 2 equals 14x plus 2. Solve that. I would get x equals 1/2. And along the same lines of this stuff in black, if we forget about this for a second, I also know that PO is 6 minus 3x because these two, like we said earlier, have to be equal to each other. Well done, Rachel. Thank you very much. Any one of those methods is a valid way to solve the problem. Now, it's not solving the problem because I want to know what PO is. So therefore, you take any one of these x equals answers and plug it into either the 7x plus 1 or the 6 minus 3x to find the answer. And the answer here would be, let's see, half in there is 1.5, is 4.5. PO is equal to 4.5. Okay. Questions on any of those methods? We're good? Good? Excellent. Let's move on. Blah, 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 blah. Okay, I solved it a different way. There we go. All right, bisector. What does the prefix bi mean? Two. Good. Sector means to cut. So it's something that cuts something in half or in two. Now, we've used a midpoint as a bisector already, like in this first horribly pixelated picture. Okay. A is the bisector of this segment because it's in the middle and cuts it into two equal spots, but it doesn't have to be a point. It could be a line like in the second picture. It could even be a plane like in the third picture. So simply put, the bisector is a segment, a line, or a plane that intersects a line segment at its midpoint. In other words, cuts it exactly in half. Right, just a definition for you. We don't need to do this because we just finished a bunch of simplifying radicals, but it will become relevant with what we're going to do in a little bit, so I just wanted to review quickly. Simplifying a radical, most of you demonstrated mastery of this on the midterm and on the quizzes before that. But again, what numbers are perfect squares of 72? 36 and 2, which gives me 6 square roots of 2. Okay, exact answer in terms of radicals. And I had 2 others to practice, but by now you guys are good at this, so we don't necessarily need to spend time on that. Where we are going to spend time is reviewing the Pythagorean theorem. Anybody? What's the Pythagorean theorem?
A squared plus b squared equals c squared.
Perfect. Okay. If you ask anyone on the street, they're going to tell you a squared plus b squared equals c squared. However, this is another way of saying the same thing. So let's talk about some terminology. First of all, this is a right triangle, meaning it has a right angle in the triangle, 90 degrees. These 2 short things are called legs. The longest side here is called the hypotenuse. And you knew this already because you've done this a bunch. You guys have seen this before, right? Okay, good. For those of you at home, you've all done Pythagorean theorem problems, right?
Yes.
Yes.
Beautiful. All right, let's see how good you are at it. Solve that problem, please. Lily, how long is C?
Um, 13.
Perfect. Tell me what equation you set up.
5 squared plus 12 squared equals c squared.
Whoops. Jumped the gun there. Sorry. Good. Because we know the 2 shorter sides, that means we're solving for the hypotenuse. So we're looking for C here. 25 plus 144. C squared is equal to 169. C is equal to plus or minus 13. Okay, remember when we were solving algebraic equations, when we take a square root, we get a plus or minus. But that's ridiculous because we're solving for distances, so we just get 13. Thank you, Lily. Good job. Common mistake here is they put the C in the wrong place. So you do something like 5 squared plus C squared equals 12 squared. This has to be the longest, whoops. This has to be the longest side when you're done doing the calculations. And again, you've all done this before, so let's get rid of this. And try one more. Draw a picture, plug in your values, solve. And notice we're looking for the shortest side now. So that should tell you how big the hypotenuse is. Don't be bashful about busting out those calculators. Especially on a problem like this. I'm sure some of you don't know what this 14 squared or 25 squared is. Marin, what equation did you set up?
14 squared plus x squared equals 25 squared.
Perfect. I believe 196.
Yeah.
Okay, 625. So x squared is equal to 429. Is that right? Is the square root of 429 a nice answer? Anybody? Is that a perfect square? Square root of 429?
No.
No. Okay, so if you take the square root of that, though, you will get 21 point something? 20 point something. What is it?
20.7.
Say again?
20.7.
20.7. Okay. That answer is fine. However, if the problem said exact answer or find the exact length, then we would simply leave it as the square root of 429. Okay. Exact answer, approximate answer. And in this case, since it didn't specify, I'd stay with the 20.7. Okay, good. Nice, easy review for you. The reason I did Pythagorean theorem now is because I want to deal with distance formula. And the distance formula, I'm sure when you did distance formula in middle school, they gave you the formula, you went home and memorized the formula, and then you just did a bunch of calculations. However, what I think is important is understanding where the distance formula comes from. The distance formula is used to calculate the distance between 2 points on a coordinate plane. So I'm going to show you this derivation. I don't necessarily know if you need to write this down, but this is where that formula that you've used already comes from. So I'm going to start with a coordinate plane, and I'm going to put two random points on it. It doesn't matter where they're located. The first point is labeled x1, y1. The second point is labeled x2, y2. And I want to find the distance between them, which I call d. That's my goal. And in order to do that, I'm going to make this picture into a right triangle using we'll start with a red segment, a vertical red segment. And I have to be able to count how far, not count, but calculate how long that red segment is. If I have a vertical segment like this, its length is going to be the difference between this y value and this y value. Okay, so let's suppose I come over here and I've got a point here and I've got a point here. If this is at 1, 2, 3, 4, 5, 6, 7, this is at 8 and this is at 3, then this distance would be 5. The same idea is happening here, but I don't know the distances. So I can just call that distance y1 minus y2. The top y value minus the bottom y value. Then we do that again with a horizontal distance. This time it's blue. Get that out of there. Using the same concept, I can get an x value there of being x2 minus x1. Sorry, x1 minus x2. And the way I've done this, I now have a right triangle. Therefore, Pythagorean theorem applies. I take a squared plus b squared, and that's going to equal the distance, or the hypotenuse squared. But I don't want the distance squared, I want just the plain old distance. So I would take the square root of both sides, and that monster is the distance formula. And I know you've all seen that before. I'm almost sure you haven't seen this before, though. So again, some of you are just going to write that down and memorize it. And when you do that, without a lack of understanding, you're going to screw up on the signs here. You're going to forget to square them. You're going to forget to take the square root. Whereas if you understand where the formula comes from, then things start to make a little bit more sense when you're putting that formula together. Right? Yeah, okay. All right, everybody good to go? Let's do some examples. exact distance. So if you get an answer that involves a square root, do not pick up your calculator and give me a decimal value. Simplify the square root. Okay, go. Can you guys talk while you're working? Are you enjoying being back in the building?
Yeah.
And you're both here by choice, mom and
Yeah.
dad? Mom and dad, because I had one kid in one of my other classes who was petrified, but their parents were making them come back to school, which is a little rough. It does suck, though, that you won't be back until, let's see, I won't see you again until you have, this is day 2?
Yeah.
So today's Tuesday, so Wednesday, Thursday, you're off. Then Friday, Monday, so I won't see you again till Tuesday?
Yeah.
Oh, that's
Working day.
All right, I'm gonna rely on one of you for the answer on this one.
What do we do first?
What do you mean? On this? Plug and chug into this formula. Because you're looking for D between those 2 points. All right, Aiden, you got a setup for me at least?
Yeah.
And I'll take it from there? Okay, go ahead. Whoops. Distance is equal to the square root of, okay, go.
-3, comma, -5 to the second power. Or
Ooh.
actually,
No. Notice x1, y1,
yeah.
x2,
So it
y.
would be 4, right?
Yeah, -3 minus 4, quantity squared, plus
Plus -5 minus 6, or plus 6.
quantity squared. Everybody good at home with that? Now, some of you may have chosen to do it the other way around. You may have called this x1, y1, and the other one x2, y2. It doesn't matter. You'll get the same answer. -3 minus 4 is -7 squared is 49. -5 plus 6 is 1 squared is 1. Oh, I got a little crazy here. Hold on, let me get rid of that. Which is equal to the square root of 50, which by now, with all our vast skills in radical reduction, we would know that that's 5 square roots of 2. And again, no decimal answers. Because it says exact in the problem, our answer should be in terms of a radical. Questions from anybody at home? Questions from you two, Jamokes? No, we're good? Excellent. Second problem. Approximate distance. Now, this time, when you get a radical answer, you're going to pick up your calculator and do a decimal value rounded to 2 decimal places. Kira, how do you have it set up?
I'm still doing it.
Well, yeah, I understand, but how did you set it up?
Oh, D equals 1 plus 6 quantity squared plus 1 plus 14 quantity squared.
Not bad except for two small problems. Those should be minus.
Okay.
Okay, because of the original formula that you're subtracting those values. Equals the square root of negative 1, or 1 minus 6 is negative 5 squared is 25 plus 1 minus 14 is negative 13 squared is 169, which equals the square root of 194, which is approximately, Phil, help me out there. Square root of 194, that's a 9. Thank you very much. Okay. Aside from being able to do the distance calculation, also notice the difference between exact answers and approximate answers. Our exact answer is in the form of a radical value, and our approximate answer is a decimal equivalent.
That's 9.
9?
Yeah.
13.9. Thank you. If you copy all the numbers down off your calculator, that doesn't all of a sudden make it an exact answer. Okay? It should be in terms of radicals. Good? Good at home? Give me a thumbs up if you're okay.
Wait, how'd you get the decimal?
He typed the square root of 194 into his calculator.
Okay.
Okay? Good. We're all done. Day 2. Excuse me, not COVID. So, as it says, we're moving on to day 2, which I'll unlock in a second. And then I think we're looking at a quiz sometime next week. I will let you know ahead of time as far as that goes. Let me stop this. I got to stop the recording.